Hi, my name is Trettin, and this is my final video for IE 441 Senior Design. In collaboration with Iowa State's IMSE department and Danfoss, I worked with Danfoss's MDM test cell this semester. So a little background on the problem. We worked with Danfoss on a test cell, and we identified the south test stand as an area of improvement. We explored the pros and cons of replacing the south test stand, and once we decided that there were more pros than cons, we made a business case for its replacement. We identified three objectives in this project. The first was to reduce operator walking and idle time by at least 15 minutes per shift per operator, which we achieved by much more than that. We ended up reducing the cycle time by 14%. Our goal was 5%. Next, our objective was to ensure that all lifts satisfy the NIOSH lifting equation. We also satisfied that. And lastly, we wanted to reduce the downtime of the test cell, the risk of catastrophic failure, and other costs of our operations such as overtime. And we achieved that objective as well. So first we completed a current state analysis. In that we did time studies. These are results for the time studies. The bar chart on the left shows the non-value added necessary, value added, and non-value added tasks. As you can see, non-value added tasks take up nearly 19% of operator time, so we identified that as a major area of concern. And the figure on the left shows operator task times. Next, we made a Yamazumi chart. As you can see, operator tasks are highly variable, with non-value added time also being highly variable and rising to high levels in some cases. Next, we completed an NIOSH lifting equation for the three major lifts in this process. As you can see, two of these recommended weight limits are 0 pounds, which is a huge area of concern considering operators are lifting over 30 pounds per lift. Lastly, we looked at the downtime in this process. The biggest issue we identified was the old computer system, which had over 70 hours of downtime. We're projecting over 80 hours of reduced downtime from implementing south test stand. So part of our solutions, this is the new layout. Big difference in this is that there's no payload conveyor, and all of the stations are much closer together, which reduces operator walking time. This is the sketch, the opera work content. This shows the Yamazumi charts for it. As you can see, non-value added time is almost completely reduced, and operator task times are much more consistent. And we also made a recommendation for the lifts. We recommend that lifting hoist be used for all lifts. Picture on the right shows that they already have two lifting hoists, so this is a practical solution. Also, the picture on the left shows that the lifting hoist can support the entire weight of the MDM, making the effective lifting load on the carrier 0 pounds. Also, we recommend an improved training procedure that's more individualized in hopes that will improve compliance. Finally, these are the annual savings. Years 1 and 2 use a loss of labor time calculation, and years 3 and 4 use a opportunity cost calculation. This is because we forecast that Danfoss will not be able to keep up with the forecasted demand in years 3 and 4 if no other changes are met. Total, you can see year 1 has over $600,000 in savings, year 2 has over $200,000, year 3 has nearly $4 million, and year 4 has over $11 million. Lastly, the financial impact of this project has a net present value of $2 million. This uses the 40% discount rate that Danfoss gave us over a 4-year timeline and the $2 million initial investment that they gave us. This means that this investment will have over a 40% rate of return. Thank you for your time.